Hi, here we are in Module 6, Lesson 10. This is the first video, and of course we're in grade 5. We are going to identify mixed operation relationships between corresponding terms in number patterns. Wow, that sounds like a lot, but you'll see it's not too bad. The word operation in math refers to multiplication, division, addition, or subtraction, right? Our four main operations that we use in math. So we're going to have mixed operations, more than one. So we'll see how that's going to work. And of course, corresponding terms are talking about our x and our y, and then number patterns. And this lesson is optional, so check with your teacher about whether you need to do it or not. I think it's pretty interesting, so you probably will enjoy it. And we're going to start by looking at Table A and Table B. Okay? And as we have for the last few lessons, we have x and y coordinates in our tables, and we're going to be looking at what are the rules. So what is the rule for the x coordinate in tables A and table B? Okay, the x coordinate, what is the rule? So what do we have to do to go from 1 to 3? That's what we mean when we're asking what is the rule. We see that from 1 to 3 and from 3 to 5, the rule stays the same. We are adding 2, right? Okay, very good. And then in table B, oh, look at that. Also adding 2. So in both of our tables, in both of our x coordinates, we are adding 2. What is the rule for the y coordinate in table A and table B? Okay, table A, going from 2 to 6 and 6 to 10, we are adding 4. And going from 7 to 11 and 11 to 15, counting up 7, 8, 9, 10, 11, adding 4, 11, 12, 13, 14, 15, adding 4. So adding 4 in both of those, right? Okay, so both of our tables are using the same patterns for the x and the y axis. Add twice as much to the y coordinates as we add to the x coordinates. So you notice that adding 4 is twice as much as adding 2, right? So we can talk about the relationship between our x and our y. Our y is adding twice as much as our x, right? So sometimes we use difficult math vocabulary. We just have to remember twice as much means times 2, right? So if we're adding 2 here, we're adding 4 there as twice as much. Now, what is the relationship between the x and the y going this way, right? So if we know our x or we know our y, can we find the other one? Looking at table A, right? 1 to 2, 3 to 6, 5 to 10. Do you notice that our y is twice as many, times 2, right? And we learned in one of our recent lessons that multiplying can have additive relationship, or we could have a multiplicative relationship. So here we have multiplicative, which means multiplying 5 times 2 is 10. Okay? One relationship, multiplying, right? One operation, one relationship. When we multiply by 2, we're going to get our x coordinate. If we multiply our x coordinate in our table B times 2, are we going to get our y coordinate? 1 times 2 is not 7. Okay, so that doesn't work. I notice that 7 is 6 more than 1. So does that work for our other coordinates? 3 plus 6 is 9, not 11. 5 plus 6 is 11, not 15, right? So that's not working. I notice that 15 is 5 times as much as 5. Does that work? 3 times 5? All right, 5 times 3 is 15. 3 times 3 would be 9. 1 times 3 would be 3, so that doesn't work either. You see how I'm looking for the relationship. So I call it guessing and checking, right? So I'm guessing maybe this is the relationship, checking with the other ones to see if those are working. They are not. Okay, so the trick here is that to go from our x to our y, we have two operations, not only multiplying, not only adding, maybe adding and multiplying. Okay, so that's what we call a mixed operation relationship, and we're going to be looking at that in today's lesson. Okay? All right, so still continuing with table A and B, we are going to plot these points, and this is actually in your book, in your magnifying glass page for lesson 10. So go there now and you will see these same tables A and B, pretty close representation, and then you're also going to see a grid. Okay? All right, and our coordinate grid, we're going to do it with two different colors. So you can use what you have. There's a little block there where you can color in. I'm going to say this reddish purplish color is going to be my table A, and then I'm going to use a green for my table B. You can use whatever you have and just put your code there so you know which one is which, and you can do it with me if you like. I'm going to start with my table A, which is my reddish, and hopefully we're pretty good at plotting our points by now, right? We know our x and our y are going to go across 1 and up 2. So my x is 1, my y is 2, so my point is going to go right here. And then 3, 6, 5, 10. Double checking that I'm on the right line. Looking good, and they line up in a nice line. Then I'm going to do the same thing except in green for my table B, and you have it there in your book. I'll just flash it back over here. 1, 7. So I'm going to use my same coordinate grid. 1, 7, 3, 11, and 5, 15. Okay, that is an interesting coordinate grid, isn't it? Let's talk about it a little bit. In both tables, we determined that the rule for the x-coordinate was add 2. Remember? Add 2, add 2. We had the same. And the rule for the y was to add 4. Where can we see these rules in the graph for each set of points? Okay, so now looking at the graph, we can see our x is going to be across 2 and up 4, right? Sorry, I meant table A. Our x is across 2, and then our y is up 4. And table B across 2 and up 4. So they're both following the same pattern. That's pretty interesting. And we can see the x-coordinate are the same in both tables, right? And we can see that on the graph. 1, 1, 3, 3, 3, 5, 5. You see that on the graph? Okay, that's interesting. And compare the locations of the points from table B to the locations of the points from table A. So this is a little bit interesting because we can look at our points for, sorry, moving that around a little bit too much. We can look at our points from table B and our points from table A, and do you notice, get a different color here, maybe blue, and we can see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our table B points are 5 higher than our table A points, right? 5 units up. and we can see that pattern. We can multiply the x coordinates on table A by 2 to get the corresponding y coordinate, right? We talked about that before. Each y coordinate on table B is 5 units more than the corresponding y coordinate on table A. Look at that. 2 plus 5, 6 plus 5, 10 plus 5. That's an interesting relationship between y coordinates, isn't it? How can we use this information to determine a relationship with two operations between our x and our y here? I think the point is that since they're both have the same pattern here, but this one is 5 more than these, right? So this is 2 times plus 5. So could we use 2 times plus 5 to go from x to y here? That's kind of interesting. Let's see. I think in your book you have, no, we don't have a table for that. So that's going to be the next time. But let's look at this pattern. 1 times 2. 1 times 2 is 2. Plus 5 is 7. 3 times 2 is 6. Plus 5 is 11. 5 times 2 is 10. Plus 5 is 15. All right, so we see a mixed operation where we're multiplying and adding. Okay, very good. Well, in the next video, we're going to talk more about some mixed relationships, and we'll be on page 2 in your Learn book. Sorry, not page 2, number 2 in your Learn book magnifying glass. All right, thanks so much. Aloha, I'll see you there.